Hey guys, this is episode 2 of the series Let's Make a Game 2.5D platformer. Today we'll be looking at jumping and what it takes to make a smooth jumping experience for the player. If you've played games in the platformer genre before, you'll probably notice that the games are fun to play because the controls feel so smooth and responsive. You don't have to spend much time thinking about the controls and rather get to focus on the run and jump challenges the game gives you instead. Today we're going to make those kind of controls. If you haven't watched the previous episode, make sure to do that before watching this video. It'll help you get Unity and Visual Studio set up the project, and get a moving character. You can check it out here in the card or in the description below. Alright, let's get started. Our player is sitting on a lonely little platform, and that alone won't help us test out jumping today. We're going to need another platform. Rename the platform block to Platform, and drag it into the prefabs folder so that we can duplicate it. Now drag it into the scene hierarchy and set the position to 15, -2, 0. That should give us a good amount of room to jump. Open the player move script. We're going to declare a couple of variables today. I'm going to rearrange some of the variable declarations real quick because I like things nice and organized before they become a hassle. I like putting public variables on the top and private variables on the bottom. First, declare a public float jumpSpeed. This will determine the force of the jump. Next, declare a public vector2 jumpCheck. This is going to be used to help detect the ground. A vector2 in this case is just two float values, one being the x-axis and the other the y-axis. We'll use this to determine the width and depth of a ground check test. Remember where to go for the input manager? We're going to set up the jump input, or at least see where it's already set up, as Unity has a basic input set up by default. Go to Edit, Project Settings, Input Manager, and go down to Jump. As you can see, it's already the spacebar, so we're good there. If you want to change it to a different button, change the name of the key in the positive button space. Let's declare some more variables in Visual Studio. These ones will not be public. Underneath float horizontal axis, declare a bool jump and a bool grounded. The first bool, jump, will tell us if the spacebar is pressed, and the second bool, grounded, will tell us if the player is touching the ground or not, so they can't jump in midair. Now we're going to make the player jump. Inside fixed update, where we set horizontal and horizontal axis, type jump equals input.getButtonJump. Now jump will be assigned as true or false, depending on whether space is pressed or not. Next, make an if statement. If jump, then rb.addForce 0f, jump speed 0f. Now when we set jump speed in the Unity editor, the player will have force applied to them upwards, so they'll jump. Save and build, Ctrl S and F6 for Windows users, Command S and Command B for Mac users, and let's test. First, set the jump to something, preferably in the hundreds. I'm going with 300 as that's what I used in the final product. Also, go to Project Settings, Physics, and set the gravity to 0, -15, 0, so that the player won't be super floaty. As you can see when we press play, the character flies away when you hold spacebar. We need to set up the ground check test now. If you're finding the video helpful, make sure to subscribe. It really helps to support me as I make more content for you guys. We're going to set up a function of our own now. Do you notice how the start and fixed update functions have the word void in front of them? That basically means they don't return a value when you run them. They just do a script and that's it. We want to make a function that will return a true or false, aka a bool, to see if the player is grounded or not. Type bool, since the function will return a bool, then CheckIfGrounded, parentheses, curly bracket, enter. The idea is to send 3 rays, called Raycasts, straight down beneath the player to check if the ground is there. One on the left edge, one in the center, and one on the right edge. Why 3? Well, if there was just one and the player was on the edge, it wouldn't detect ground, and so you wouldn't be able to jump when you're on the edge. So we'll send 3 Raycasts straight down, and if any one of them detects ground, then the player is grounded. Next, we're going to declare some variables, but we'll only need them for this function. If you declare a variable inside a function, it's called a local variable, and you can't call it elsewhere. We're going to declare 3 private bools, cast1, cast 2, and cast 3. So bool cast 1 equals Physics.Raycast transform.position, where the ray will be sent from, the center, comma, negative vector 3.up, also known as the direction down, comma, jumpCheck.y. JumpCheck is going to tell us how wide apart the raycasts will be with the x value, and how far down the raycasts will go with the y value. Cast 1 will send a raycast from the center. Bool cast 2 equals Physics.Raycast transform.position minus new vector 3, parentheses, jumpCheck.x, comma, 0f, parenthesis close, comma, negative vector 3.up, comma, jumpCheck.y. So basically this one will send a raycast down from the left edge, since it gets its x value subtracted from by the jumpCheck x value, and has a length of the jumpCheck y value. Cast 3 will be the same, just with addition instead of subtraction to make it on the right edge. Bool cast 3 equals Physics.Raycast transform.position plus new vector 3 jumpCheck.x, comma, 0f, negative vector 3.up, jumpCheck.y. Now we have to return whether or not any of these raycasts hit anything, so that our bool function can return true or false. Type return cast 1 or, and you type or by putting 2 vertical lines, which you can type using shift backslash, cast 2 or cast 3. This will return true if any one of the 3 raycasts hit the ground. If we wanted all 3 to have to touch the ground, we'd change the or sign to 2 ampersands, or and signs. One last step before we test again. We haven't actually specified whether or not to jump if it's grounded. We just have a function that will check it if it's grounded, but it's not called anywhere yet. Go in between these 2 if statements in fixed update, and let's set the grounded variable. Grounded equals CheckIfGrounded, parentheses, semicolon. Now inside the if jump statement, put if grounded, curly bracket, enter, then move the rb.addForce inside the if grounded statement. Also put grounded equals false after that, just to be safe. Save and build, and specify where the values of jumpCheck will be. I put 0.5 in the x value and 0.7 in the y value. Now test. It should now only jump when the player is touching the ground. However, it always jumps the same height no matter how long you hold the spacebar. Since platformers need to be responsive, we're going to want it to change along with the jump height, depending on how long we hold the spacebar. To do this, we're going to mess with gravity. Inside the if jump statement, we're going to make an if-else statement inside. If rb.velocity.y, the player's y velocity, is greater than 0, curly bracket, enter, then Physics.Gravity equals new vector 3, 0f, negative 15f, 0f. Else, curly bracket, enter, Physics.Gravity equals new vector 3, 0f, comma, negative 30f, comma, 0f. Underneath the full if jump statement, let's put an else underneath that. And inside that, we'll put Physics.Gravity equals new vector 3, 0f, comma, negative 30f, comma, 0f. So basically, this will decrease gravity if the spacebar is held and the player is jumping upwards as well. And gravity will be stronger if the spacebar is not held or if the player is falling down. Save and build and test. It works pretty well. Try holding down the spacebar for different amounts of time. The only thing we have left is to edit the camera so that we can actually see the player when they jump to the right platform. Create a new script and call it camera move. Open it and declare a couple of public variables. Public GameObjectTarget, which will be assigned to the player so the camera can reference it, and public vector3 offset, which will tell the camera a certain position to be away from the player. Delete the start function. Inside update, type transform.position equals target.transform.position plus offset to set the camera's position to the player's position added to the offset. Save and build, and attach this script to the camera. Drag the player from the scene hierarchy into the little target slot and set offset to 0, 1, -10. You can mess with these values if you want. They won't really make or break your game. Now we have a full running and jumping character. Congratulations! In the next video, we'll be looking at building up the level a bit more and coding what happens when the player falls out of the world. Good work, team. We're one step closer to making an absolutely fantastic game. You've learned about custom functions, local variables, raycasts, and how to edit gravity today. If you liked the video and want to see more, subscribe and make sure to watch the rest of this tutorial series. You can also check out some of my other videos if you're into music or you're a little more experienced in game design and want to see the games I've made. You can also support me on itch.io. If you have any ideas, questions, or funny jokes, put them in the comments below. And remember guys, life's a game. Have fun with it.